Hello students, I am Diganta Bora, your new chemistry teacher. Today we will discuss about the second chapter of first book, that is solutions. Okay, we all know a solution is a homogeneous mixture of minimum two components. One component is called solute and the another component is called solvent. So that means when solute and solvent are mixed, then we will get solution which is a homogeneous mixture. Okay, now solute is that component which is present in lesser amount and solvent is that component which is present in higher amount. Or we can also say that solute is that component which is dissolved, and solvent is that component on which the solute will dissolve. Okay, so therefore you can say that in a solution minimum two component is present. More than two component may be present, but minimum two component is necessary. One component is called solute and the another component is called solvent. Generally solute is present in lesser amount and the solvent is present in higher amount. Again, in another words, we can say that the component which is dissolved or which is disappear during the formation of the solution, that component is known as solute, and the component on which the solute will disappear or dissolved is known as solvent. Okay, now we can take example. Suppose you have taken some common salt, that means sodium chloride, and you dissolved it or you mixed it with water, then you will get a solution. That solution is known as salt solution. You can observe it right now. Take some sodium chloride or common salt from your kitchen, then mix it with water. What will you observe? You will observe that the sodium chloride is dissolved or sodium chloride is disappeared. So therefore sodium chloride is solute and the water is solvent because sodium chloride is dissolved in water, and the resultant mixture we get is homogeneous mixture. You will not find any sodium chloride in the resultant mixture. That means that mixture is homogeneous mixture. Okay, the sodium chloride will uniformly mix throughout the mixture. So therefore that mixture is an example of solution, and that solution is salt solution. Okay, so therefore we get to know that what is solution, what is solute, and what is solvent. These are the basic things you already studied in class 9. But in this chapter, we will discuss about concentration of solution. After that, properties of solutions, and then finally we will discuss colligative properties. One of the most important topic of this chapter, that is colligative property. Now, let me discuss types of solution. The solutions are classified into three types. First, gaseous solution. After that, liquid solutions. Then solid solutions. So we can say that solutions are classified into three types: First gaseous solutions, then liquid solutions, then solid solutions. We can take the previous example, that is sodium chloride is mixed with water, we get the salt solution. If you observe, then you will observe that the salt solution will present in liquid state. Salt solution will present in liquid state. So that means the physical state of the solution is determined by the physical state of the solvent, because water is present in liquid state and sodium chloride is present in solid state. The physical state of the solution is determined by the physical state of the solvent, not by the solute. So hence we can say that depending upon the physical state of the solvent, solutions are classified into three types. First gaseous solutions, then liquid solutions, then solid solutions. In this case, the solvent is in gaseous state. The solvent is in gaseous state. In this case, the solvent is in liquid state. And finally, in this case, the solvent is in solid state. Okay, we can take example. There are so many examples, but here I will give only one example for each. The first, in case of gaseous solution, we can take example like mixture of oxygen and nitrogen. We have a mixture in which oxygen and nitrogen gases are present. That is an example of gaseous solution. Again, in case of liquid solution, I can take example, or I will take example of a mixture of ethanol and water. Ethanol is present in liquid state and water is also present in liquid state. Both are mixed, they will form a homogeneous mixture, and that mixture is an example of liquid solution. Again, solid solutions, we can take example alloys. Alloys are homogeneous mixture of two or more solids. Alloys are homogeneous mixture of two or more metals. Okay, so these are examples of different types of solution. There are also different examples of these three types of solutions. You will find it and you will prepare a chart and you will also send it to me. Okay, next important topic, that is concentration of solution. Our next heading is concentration of solution. Concentration of solution is very easy. Suppose I have a solvent. Okay, I have a solvent and I add a solute in it. Okay, then finally I get the solution. I get the resultant solution. Okay, now in the resultant solution, the amount of solute present is known as concentration of that solution. Or we can say that the amount of solute present in a given solution is known as concentration of that solution. Suppose I have 1 liter of solution. Just imagine the volume of the solution is 1 liter and I added suppose 2 mole of sodium chloride. Okay, then the amount of solute present in the given solution is known as concentration of this solution. Okay, and concentration can be expressed in different ways. We will discuss now. Okay, so therefore first the concentration will expressed in mass percentage. The concentration will express in mass percentage. You already studied about this topic in class 11, mass percentage. Suppose the mass of the solution is x gram and the mass of solute we added is y gram. Okay, we have seen that in x gram of solution, y gram of solute is present. In x gram of solution, y gram of solute is present. Now, in 100 gram of solution, y by x into 100 gram of solute will present. Okay, this is known as mass percentage. That means the amount of solute present in 100 parts of the solution is known as mass percentage of that solution. The amount of solute present in 100 parts of the solution is known as mass percent of that solution. Now we will convert this into a formula, and after that we will use this one. Okay, y is mass of solute, so therefore we can say that mass percentage equal to mass of solute. After that, x is mass of solution, so therefore mass of solution will be here into 100, and we say mass percentage, therefore percentage symbol will be here. So this is known as mass percentage, and this is one way to express the concentration of a solution. After that, the next way to express the concentration of solution is volume percentage. Volume percentage. Okay, in this case, volume percentage equal to volume of solute by volume of solution into 100%. That means we can say the volume of solute present in 100 parts of volume of the solution is known as volume percentage of that solute in the solution. Okay, I am again repeating, the volume of solute present in 100 part volume of the solution is known as volume percent of that solute in the solution. The next concentration term is mass by volume percentage. I am writing here mass by volume percentage, and mass by volume percentage will be mass by volume. So therefore here mass of solute, mass by volume, here volume of solution percentage, therefore into 100%. Therefore here we learn about how to express concentration of a solution. First mass percentage, then volume percentage, then mass by volume percentage. We will solve some problems related to these concentration terms. Okay, there is another way in which concentration is expressed. Number 4, parts per million or ppm. If you observe a blood report, then you will see that suppose component of a blood is present like this, 1 ppm. If you have any blood report right now, you can see it. Okay, some components are present 1 ppm or 0.5 ppm, okay, or it is mentioned that this component must be present like this from 5 to 7 ppm, okay. That means that component is expressed in parts per million, or that concentration of that component in blood is expressed in ppm, parts per million, okay. Suppose a component is present in a solution in very less amount, very less amount, okay. If we express it in terms of 100, that means percentage, then also the result is very less. Then we will express the concentration, or we will compare the concentration, or we will compare the amount of that component in 1 million of the solution, okay. Here we will not compare in terms of 100, we will not compare in terms of 1000, because the component is present in very less amount. Therefore we have to compare the component in terms of 1 million of the solution, so that the result will become high, okay. So therefore parts per million is expressed like this. Parts per million equal to number of parts of the component which concentration has to measure, okay. Number of parts of the component divided by total number of parts of the component. Total number of parts of the components in the solution. Here component, here I write components because in the solution 2 or more components are present, into 10 to the power 6. This is the expression for parts per million, okay. Next, the concentration is expressed in another way, that is mole fraction. Number 5th, mole fraction. We know fraction means ratio. Here mole fraction, that means ratio of moles, okay. Suppose we have a solution. Just imagine you have a solution in which 2 components are present. One is A, another is B. You have 2 components in a solution, one is A, another is B. Suppose number of moles of component A is Na, and number of moles of component B is Nb. Now mole fraction is the ratio between number of moles of that component. Suppose we have to calculate mole fraction of A, then mole fraction of A equal to numbers of moles of that component which mole fraction has to calculate. Here we are going to calculate the mole fraction of A, so therefore it is the ratio between numbers of moles of A divided by total number of moles of the solution. So we will get total number when we will add them, that means number of moles of A plus numbers of moles of B. So this is the expression for mole fraction of component A. So here mole fraction of A, and mole fraction is expressed by X, that is X A equal to number of moles of A divided by total number of moles of the solution, and we will get the total number when we will add numbers of moles of different components present in the solution. Similarly, you can find mole fraction of B, Xb equal to numbers of moles of that component. We are going to determine mole fraction of B, so therefore numbers of moles of B divided by numbers of moles of A plus numbers of moles of B. That means total number of moles in the solution. So therefore you can say that mole fraction is the ratio between numbers of moles of a component in the solution to the total numbers of moles of the solution. Okay? Our next way to express concentration is molarity. But before studying molarity, let me add XA and XB. XA plus XB equal to, the value of XA is this one, Na by Na plus Nb, plus the value of XB is this one, Nb by Na plus Nb. Okay, the LCM will be Na plus Nb. Okay, then here Na plus Nb. So that means they will cancel out each other and the value is 1. So what we get when we add the mole fraction of different components in a solution, then the result will be always 1. Suppose in a solution there are 3 components and their mole fractions are XA plus XB and XC. Then here the result will be also 1. So you have to remember it. When the mole fraction of different components present in the solutions are added, then the always result will be 1. Okay, and you have to remember this one because there is an application of this formula in later part of this chapter. Okay, the next way to express the concentration of a solution is molarity and molality. One is molarity and another is molality. So these 2 topics will discussed in next class, and in this class we have studied about what is solution, water, solute and solvent, and after that types of different solutions. Okay, then concentration of a solution and different ways to express the concentration of a solution, and we will study about molarity and molality in next class. Okay, thank you.